Hi everyone, welcome back to Power Electronics session 7. Here we will discuss about the one of the important commutation circuit, that is class D or voltage commutation circuit. So to discuss about this voltage commutation circuit, we will use the DC to DC converter as an example. What exactly mean of that? DC to DC converter is nothing but like this constant DC voltage will be used to control the load voltage, nothing but either increasing the output voltage or decreasing the output voltage. But we are not going to discuss about exactly how this step up or step down will be happening. That we will discuss in the DC to DC converters. To control this output voltage, we need to turn on the thyristor Tm. As we know, we can turn on the thyristor T1 by using gate voltage. There's no problem in that. We already discussed. But now here, to turn off this conducting thyristor, what circuit is required? That means how we can actually turn off this. Turn off this thyristor, we need to have an additional circuit. What is the additional circuit is required? So that's what we need to discuss here. So here we require the tank circuit. So tank circuit is nothing but capacitor, which is already charged. Then we require one additional thyristor, that is auxiliary thyristor here. As I told you, the tank circuit means capacitor we already taken. Now we need to take the inductor. Then we require one diode. Okay, so this one. So as I told you, like here we need to, that means tank circuit is nothing but charged capacitor. Generally, if we need to charge the capacitor like this. Okay, so that's what we require. So here, like to turn off this thyristor, like this thyristor, we require all this extra circuitry. So that is called as a commutation circuit. So one additional thyristor, then inductor and capacitor, nothing but tank circuit. So this circuit is required to turn on this conducting thyristor. That we can discuss. But before going to discuss about other things, here one of the assumptions is nothing but load is always drawing a current of I0. That means it's a constant value. When the source is not supplying the current means freewheeling diode will actually supply that. That's not freewheeling diode will be in conduction, then load will actually having the freewheeling period there. Okay? So now we will discuss about the operation of this commutation circuit. Okay, so here, as I told you, like two assumptions. One is nothing but capacitor must be charged like this. That's nothing but like initial voltage across this one is same as the source voltage VDC, and other one is nothing but load current is constant I0. Okay, so that. And as we discussed already, like a thyristor here which is required to turn off the conducting thyristor, that's called auxiliary thyristor, and the thyristor which is to be turned off, that's called main thyristor. So rest of the things are unknown. So now we will discuss about the operation first, then we will discuss about in equivalent circuits, then we will discuss the waveforms. So now if you look at this one, so initially, like this thyristor is not in conduction, so that means this thyristor is not state. If it is not state, then it is like kind of like a open circuit. Open circuit means it is open like this. Okay, so now this thyristor is actually like open circuit, then like there is no current from the source to load. Now see that, is there any path to discharge the capacitor? Capacitor will discharge from the positive plate only, but this voltage and this voltage, as we already discussed, both are same VDC. That means it won't go like this, and it will try to discharge like this, but this thyristor is open circuited. That means there is no path to discharge the capacitor. That means capacitor voltage remains same. Now to supply the power to the load, we need to turn on the main thyristor by giving the gate voltage. If you turn on the main thyristor, then it will act as a short circuit. Now there will be two currents flowing through the main thyristor. One is load current I0, which is required to supply the load, that is coming from the source. And additionally, we have one more current, that's nothing but now we can see that capacitor is actually found the path path to discharge. That means this capacitor discharge current, nothing but tank circuit current, will also flowing through the main thyristor like this. That means whatever the energy is available with the capacitor will be transferring to the inductor. So in this case, inductor is getting charged by the capacitor. Okay. So initially two currents will be flowing through the main thyristor. That's nothing but load current I0 and other current is capacitor current. So here in this case, once all the energy transferred by the capacitor, so now if all the energy available with the capacitor is transferred to the inductor, then voltage across the capacitor becomes 0. That means all energy transferred to the inductor. In that case, current will actually reach the maximum. Now, in this same path, inductor will try to discharge. That means it will charge the capacitor. That means whatever the energy is actually available with the inductor, again transferring back to the, that means capacitor again getting charged by the inductor in this direction. Current is in the same, in this direction. That's why this is positive plate and this is negative plate. Okay, so now this inductors keep on charging the capacitor. That means all the energy will be again transferring back to the capacitor. Once all the energy transferred back to the capacitor, then capacitor voltage becomes VDC again. Whatever the energy transferred to the inductor, it again got that. That means that all the energy transferred back, so voltage becomes VDC. In this case, that means inductor is completely discharged, so no current in the circuit. No current in the circuit. No current in the circuit. That means here inductor is actually completely discharged. Now this capacitor will try to discharge in this way, but this diode will not allow. So capacitor voltage is actually not, the capacitor is not finding any path to discharge. That means the equivalent circuit now is like this is open circuit. Okay, so capacitor is actually trying to discharge in this way, it is not there. So now in this duration, the current flowing through the main thyristor is only I0. So now if you remember what we discussed so far, if you look at that, once the main thyristor is turned on, what happened on the commutation circuit? Nothing but simply voltage across the capacitor is reversed. That is through the main thyristor. That means capacitor is discharged first and then again charged by the inductor. That means voltage reversals happen. Now this capacitor is ready for the commutation. Whenever you want to turn off this thyristor, main thyristor TM, then we need to turn on the auxiliary thyristor. If you turn on the auxiliary thyristor, that means you can see here, this is acting as a short circuit. Now we can see that when you turn on the auxiliary thyristor, the capacitor suddenly appeared across the main thyristor. That means this is not there, this is not there, you can see. Okay, so now this capacitor is connected across the main thyristor. If it is connected across the main thyristor, that's good, but whatever the voltage appear across the thyristor will appear across the main thyristor. What we remembered in case of voltage commutation circuit, we will apply the sudden reverse voltage to the conducting thyristor. That's what we have done. So here we actually applied the sudden reverse voltage to the conducting thyristor, that is through the capacitor. Now we can see that positive is actually appear across the cathode of the thyristor, negative is appear across the anode of the thyristor. That means reverse voltage appear across the thyristor. That means immediately this conducting thyristor will be turned off. So once the auxiliary thyristor is turned on, then conducting thyristor will be turned off because it is suddenly reverse biased. Impulse voltage we give that. Now this load current will be supplied through the capacitor, auxiliary thyristor and then load. So, but our aim is nothing but to turn off this thyristor is nothing but we need to disconnect the source from the load, but still it is actually flowing through the auxiliary thyristor. In this case, what exactly happened initially, this duration, source as well as capacitor, because capacitor is charged, Both are actually, you can see that aiding nature. This is negative and this is positive. That means aiding nature. Both will supply the energy to the load. That is nothing but during this period, capacitor is actually discharging with the constant load current. That means current flowing through the capacitor is constant, but it is discharging. That means supplying the energy to the load. So in this duration, capacitor keep on discharging means voltage across the capacitor is slowly reducing. So voltage across the capacitor is reduced means at one time this voltage capacitor will be zero. In this duration, capacitor will again charged by the load with the same load current value. That means in this duration, source will supply energy to the load as well as the capacitor. Now capacitor will start charging in this direction by the source with the constant load current I naught. Once the capacitor is again charged back to VDC, then both the voltages are same. That means current flowing through the load or capacitor will be zero. That means in this duration, that is nothing but once the capacitor is charged back to VDC, then current flowing through the auxiliary thyristor capacitor will be zero. That means this thyristor will be turned off automatically. It is like a kind of class A commutation. It is turning off because of its load current, nothing but capacitor current coming to zero. That means this thyristor is turned off. Now we can see that in this duration, load is completely disconnected from the source. That means auxiliary thyristor is open circuited, main thyristor is open circuited. So now this load current is flowing through the freewheeling diode. That means the freewheeling action. Again, same thing we can start like turning on the main thyristor and so on like that. You can see again another important point is here to start when you are starting the main thyristor, capacitor voltage should be upper plate is positive, down plate is negative. Now we can see that it is again came back to the original situation. That is the main important when you are turning before turning on the main thyristor. So then only we can actually start the commutation circuit again similar. So this is what? The same thing we can discuss with the flow, that's nothing but equivalent circuits. Remember that. So with that means, as I told you that what will happen initially from the main thyristor is open circuited to turn on, all these things we can discuss again with the help of equivalent circuits. So this is the first one, starting one. Starting one is nothing but like main thyristor is not turned on, auxiliary thyristor is not on, diode is not there. That means there is no path for the capacitor to discharge. In this way, voltage across the capacitor is actually same as the source voltage. So PDC. So now here capacitor is not discharged. That's what like no current flowing through the main thyristor and voltage across the capacitor is VDC. Current flowing through the capacitor is zero. Now if you turn on the main thyristor, then as I told you that initially two currents will be flowing through that. One is load current I naught, other current is tank circuit current IC. In this duration, capacitor is discharging, inductor is charging. That means voltage across the capacitor will be slowly reduced to zero, current flowing through the inductor will be increased to max value. That we already discussed in the tank circuit, the voltage across the capacitor will follow the cosine wave, but current flowing through the inductor or current capacitor, both are same because both are in series, will be following the sinusoidal waveform. That means in this, when they are actually reaching the maximum value, nothing but after pi by 2 radians, voltage across the capacitor will be zero, current flowing through the inductor will be maximum. Okay, still current flowing through the main thyristor will be load current as well as the tank circuit current. Once the current reaches the maximum value and voltage across the capacitor becomes zero, now the energy available with the inductor will be start supplying back to the or transferring back to the capacitor. That means in this case you can see that here voltage actually start building up across the capacitor but in the reverse direction because the current is flowing through the capacitor like this. Now, earlier it is discharging, nothing but it will act as a voltage source. Now it is charging, that means it will act as a simple load. So now capacitor voltage will be building in this way. So after pi by 2 radians, voltage across, current, that means energy available with the inductor is completely transferred to the capacitor. That means voltage across the capacitor becomes maximum, current flowing through the inductor will be minimum, nothing but 0. So this is the situation. In this situation, you can see that voltage across the capacitor again back to the old voltage, that's nothing but VDC, okay, but in the reverse direction, and current flowing to the capacitor and inductor both are in series will become 0. That means it will try to discharge in this way, but this diode will not allow that. That's why it is open circuited. That means till now what we have done, just by turning on the main thyristor, we actually reverse the voltage across the capacitor. That means we are preparing the capacitor to commutate the main thyristor TM. Now in this situation, we are ready for the commutation. Whenever you want to turn off the conducting thyristor, we need to turn on the auxiliary thyristor. You can see that auxiliary thyristor anode is connected to positive, means it's forward biased. You can turn on that. Once you turn on the auxiliary thyristor, then sudden reverse voltage will appear across the main thyristor, and assume everything is ideal, then main thyristor will be turned off. So that's what happened. So now equivalent circuit is nothing but your main thyristor is turned off, and you can see that as we discussed, load current is still supplied by capacitor and auxiliary thyristor. As I told you that capacitor voltage, that means it is already charged, that means it will behave like a voltage source, and already source is there, both will be in aiding nature. That's why during this situation, source and capacitor both will supply the energy to the load. That is nothing but capacitor is discharging with constant load current. Once it is completely discharged, the voltage across the capacitor will become 0. That's nothing but like this. So here voltage becomes 0. Now in this situation, that means after this situation, capacitor will start charging by the source itself. That means source will actually supply the energy to the capacitor as well as the load. So now in this duration, capacitor is actually keep on charging or getting charged by the source with constant load current. Once the capacitor voltage becomes source voltage, nothing but here again VDC, then this voltage and source voltage already VDC, both are actually equal. That means current flowing through the capacitor becomes 0. Once the capacitor current becomes 0, then auxiliary thyristor will be turned off. That is just like a classic commutation. Once the auxiliary thyristor is turned off and that means main thyristor is already turned off, that means load is completely disconnected from the source. So in this way, load will be freewheeling. So that means this is the complete operation of the classic commutation. Again, we'll start the same thing once you actually turn on the main thyristor, and then everything will be happening that. So these are the things we need to remember. Now the important thing is to discuss further. We need to draw the voltage waveforms and current waveforms required for this one. Okay, so that's what I'm actually talking about, the waveforms now. So here we are going to discuss about the 4 waveforms. One is like current flowing through the load I0, then current flowing through the main thyristor, then current flowing through the capacitor, that means tank circuit current, and then voltage across the capacitor. We need to draw all these things. So here if you want to draw all these things, means we need to look at like what we discussed in the previous to draw these waveforms, we need to remember the operation of the circuit. This constant load current is flowing through the, assume like a main thyristor is turned on at t equal to 0. Once it is turned on, then obviously this load current will be flowing through that, and as I told you that tank circuit current will follow the sine wave. That means it will start from 0 and then reaches the max value. So during this situation, okay, so here voltage across the capacitor will follow the cosine wave as we discussed in the tank circuit equations. That means it will start from VDC, then it will actually follow the cosine wave. So this is VDC. So now this is actually like reaches the maximum value. That is nothing but assume IC max. Okay, IC max. So you can say that ICM. So now during this situation, capacitor is actually getting discharged, inductor will be charged. Now after this situation, it will be reversed. Nothing but capacitor will be getting charged by the inductor and inductor will be discharging. So current will follow like this. So in this duration, voltage across the capacitor will be following the cosine wave. So reaches the maximum value, that is nothing but minus VDC. So during this time, current flowing through the main thyristor will be sum of these two. That means load current plus tank circuit current. So that's why it will follow like this. After happening the voltage reversals across the capacitor as we discussed. So voltage across the capacitor remains same as minus VDC. And current flowing through the capacitor will be 0. And current flowing through the main thyristor will be load current I0. Now at this situation, assume we are actually turning off the main thyristor by turning on auxiliary thyristor. Once you turn on the auxiliary thyristor, then main thyristor will be turned off here. But as I told you that load current will be flowing through the auxiliary thyristor and capacitor, that's nothing but I0, so it will follow the I0 because the capacitor current and auxiliary thyristor current will be same. During this time, load will be getting the current through capacitor, auxiliary thyristor. That's why in this period, capacitor will be keep on discharging with constant load current first, then at the same time it will charge, it will be getting charged with the constant load current. Okay, so again it is actually coming back to the VDC, then till that point current flowing through the capacitor will be constant load current. That's nothing but once the capacitor current becomes maximum, that's nothing but VDC, then auxiliary thyristor will be turned off. Once the auxiliary thyristor is turned off, then load will be disconnected from the source. From there it will actually freewheeling. That means till this point load is getting the current from the source, and this is actually nothing but freewheeling period. Okay, so now it is actually back to that capacitor voltage is back to the VDC and the current flowing through the capacitor is 0. Okay, and at this point of time main thyristor is turned off and it will be reverse biased by the sometime reverse biased by the capacitor voltage, and again it will be forward biased. So after this it is actually like ready to turn on, but when you turn on this thyristor, then again same thing will be started. So now here to complete this operation or to complete the entire thing, we need to derive some things from these waveforms. So one is, what is the maximum value of the load current, maximum value of the current flowing through the main thyristor. As we discussed, this is nothing but sum of the two currents. One is capacitor current, other one is load current. But here at this time it is maximum. Maximum means it is I0 plus maximum capacitor current is nothing but ICM. So that's the maximum current. And assume this is the, to complete 1/2 cycle means it is a 5 radians. Okay, you can take this is the T1 seconds, this is T2, this is T3, and here this is also important time, that is called, take it as a T4, then T5, and so on like that. Okay, so now we need to derive few things here, that's where we can look at that. So first thing is, as we discussed from the waveforms, you can see that what is the maximum current flowing through the main thyristor? It is I0 load current plus IC max. But how to calculate the IC max? as I told you that from the tank circuit equations, if you remember, IC is nothing but initial voltage across the capacitor. But here, in this case, initial voltage across the capacitor is source voltage VDC. So VDC into root of C by L sine omega naught. So that is the equation. But here it is just like a kind of like sine wave, I maximum and sine wave. So that means this is the IC max current. Okay, so this is the IC max. So that means here maximum value of the current flowing through the main thyristor is, so here finally like maximum current flowing through the main thyristor is I0 plus source voltage VDC into root of C by L. So this is what you need to remember. Okay, and another one we need to look at what is the maximum value of the auxiliary thyristor current. First of all, if you look at all these waveforms, when the auxiliary thyristor is in conduction, that means when the main thyristor is commutated, that is nothing but from the T3 onwards. T3 onwards, what is the current flowing through the capacitor, which is same as the auxiliary thyristor current? That is nothing but, as we already discussed, this current is nothing but load current only, I0. Okay, so that means maximum current flowing through the auxiliary thyristor is nothing but I0. So these are the two important equations we need to remember with respect to voltage commutation circuit. Okay, so another important thing is when you turn on the main thyristor here, you can see that what is happening on the voltage, capacitor side, voltage is actually reversing. That means it is from VDC to minus VDC it is happening. That is the minimum on duration it is required to commutate the thyristor. So this is what important. That means once the capacitor is actually like voltage is reversed, then only it is ready for the commutating the main thyristor. That means main thyristor must be in conduction to have this commutation ready. So how long it should take that? It is nothing but pi. So it is the minimum on duration of the main thyristor to have the proper commutation. So minimum on duration of the main thyristor to have effective commutation. Okay, so that is nothing but T equal to pi by omega naught, because omega naught equal to pi, that is nothing but pi into root LC. So this is required to have the voltage reversals across the capacitor. There are two problems here in case of voltage commutation. First thing is, as we discussed, so commutation operation of the circuit, that means operation of the commutation circuit is depending on the minimum on duration of the main thyristor. That means here if the load is actually drawing very light current, very low current, in that case on duration of this is very small. In that case we can't make the voltage reversals across the capacitor. That means we can't turn off this thyristor. That's one of the important problem. Okay, so that's a problem one. There is a other problem here. That's a problem is nothing but, you can see here, generally the current flowing through the main thyristor, that means main thyristor is only to supply the load current only. That is nothing but the rating of this thyristor, current rating of this thyristor depends on the load current. But in this case, apart from the load current, this main thyristor is carrying some additional current, that is only from the commutation circuit. That is why the size of this thyristor should be more than load requirements. But that is also only for short duration. It is not required for entire duration. So that means unnecessarily we need to increase the size of this one, and we are not effectively utilizing that overall size also. That is another problem with respect to voltage commutation. So these issues will be overcome by the current commutation circuit, nothing but class B commutation. That we will discuss in the next video, and we will close the commutation circuits in the next video. Thank you.